This is me. I'm a software developer. I've been working in the field of cognitive computing from a symbolic perspective during 11 years. This has made me kind of shy when I have to speak to many people because I've been recruited in a room many times. 1 year ago, I founded Atomian with some partners. Some of them are here to support. Our main asset is a cognitive architecture I've built during these years. A cognitive architecture is not exactly NLP. I would say it's more about understanding the information and considers language as one of the features to represent that information. So Atomian does not rely on a single idea, a single brilliant idea that can explain everything. It's a complex, long theory built from many influences, many studies, many assertions, many hypotheses. Have an idea that our engineers take more than 4 months to fully understand the theory before they can start building code. So and keep in mind too that my primary intention was building a robot brain, not an NLP artifact. I think I'm in the way, but the applications we found are in the field of NLP, or more, I would say, understanding than processing. Well, here are some of the fundamental ideas that I used as the premises to build Atomian. It's partly in the way Elena has told, but slightly different. First of all, the words are not the things. Probably in your brains you have the ideas without the words, and then you have words that mean those meanings or that meaning, but the word is not its representation. That is crucial in Atomian, because when you say home, you are pointing not to the concept of home, but to the word home, and then the word home has a meaning, which is the home. My second fundamental premise was describe the world with concepts, a part of the representations. Use atoms as minimum pieces of information. This should be our only brick. This is what I did. And this way, if you see this first drawing, home as a representation is an atom itself. But word is another atom, and things that you don't see here. This word is of a kind. This relation of the word and its kind is also an atom. And the relation of belonging with the word to the language is another atom. And this last line is another atom. And finally, the concept. In this case, home would be a class of things, or when someone thinks about his own home and is an instantiation of that class. I'm not the first one to state things that way in cognitive architectures. And last one, no, 2 last ones. The 4 is important. Build the theory in a way that you can later explain Atomian to Atomian. So make Atomian understandable for Atomian. This is what proves that really Atomian is complete in terms of representing information beyond the words. And finally, make it deterministic, meaning for the applications we found, if you ask 50 times with different words for a thing, it should give you back always the same answer. So this is the difficult one. This is like part of the information flow and the main modules or processes or process areas, I would say, in Atomian. First of all, I'll use this pointer. Sorry. First of all, we have a universal data model. It took me 5 years to develop this model. A priori, it's capable of storing every kind of knowledge humans or our machines can generate or understand. So it's virtually the ultimate data model you will need in your life, a priori. And it's based in atoms. That's why the name of the company we founded. And then we, as I showed you, atoms are not only standing alone, but there are relations between atoms that are also atoms. And these are binary or tertiary or quaternary. So you need a data management layer. Because if you say, Miquel, and this brings you to your family and to your job and to your friends, and you're finally in your, I would say, your short-term memory, or the PC memory, or the server memory in this case, would load everything. This would be unpracticable. So you need that data management layer. And then you have this general information flow. You have a perception that you collect in some perception artifacts that send them to the interpretation module. Here is where language is interpreted, really. Later I'll show something. Once you have interpreted, I mean, if I say a green elephant flying on the Sagrada Familia, I think everything can understand what is it, but when you explore that meaning that you acquired, you know it's false, it's a joke. And then goes the thinking. After you perceive, interpret, and explore, you have a set of symbols that you can think about to produce your answer, to think about your answer, to generate, define your strategy and think. And finally, the action artifacts are more mechanical. I would say in a chatbot, the only perception artifact would be the socket and entering the sentence, and then. But this makes us partly an API. So as you see, this is what we call a cognitive architecture. There are many cognitive architectures. CD is working with a quite old cognitive architecture. There are many others. We don't have a great definition for what this is, because there are many different approaches. But I would say it's circular. But I would say cognitive architecture is a formal description of the cognitive processes and structures that take place in our neocortex, which is the outside layer of our brain that contains the human abilities, typical human abilities. Meaning Atomian doesn't manage motor processes, which are in fact outside our brain. But it does with emotions. They are not in neocortex, but they influence very much in neocortex. That's Minsky, who said that we have societies of neurons, the society of mind. He said societies of neurons that are competing to win our attention and define our output that way. And this had much relation with the emotions you have in that moment that move you towards a response or another. Talking about language, for us, language is an expression of that information, which is 100% symbolic. You have a sentence. In interpretation, you have to turn it into a set of symbols. And this set of symbols is already computable against your knowledge base, which is built with your data model. And then when you do that computation, you have your results, which are more symbols. And you have to verbalize that symbols. That's the final step. And this is where Atomian is quite different to many other techniques of NLP and cognitive architectures. They rely completely in words. Words, rules, words. Here is words, symbols, symbols, computing, symbols, decision, and finally verbalization for this case of language. I have to say, I had to develop a completely new theory of language during maybe 3 years in order to put things together with my data model. Because for me, a sentence, language, is just an expression of some symbols you already have or you create while you listen. If we change slightly this view, you will see why, from my point of view, natural language understanding, not processing, which is a quite different technique or approach, is an API. This dot line shows a clear input and an output, and that's in the very nature of language and how we use it, speaking, listening, except by women that do both at the same time. There's one thing I want to say too, and this has neurological support and scientific support. The process of understanding and the process of verbalizing are completely different in a language. And there are reported cases of people learning a new language, people that understands better than talks, and the opposite, people that don't understand but can speak English for hours, like me. What's the main advantage. And I'll go out to comment the Elena thing. I want to. With natural language understanding based on symbols, you guarantee that all these things are the same, which is London, in fact. You don't need rules for every sentence. You don't need large Bayesian multidimensional networks to understand that you have to answer London, because Atomian really gets to know that this city you're talking about is London. This is the major breakthrough for me in Atomian. Talking about morphology of the words and suffixes and what we generally call suffixes in Atomian, it's true. Where is Elena? It's true that you use suffixes sometimes, but some other times you already have a meaning for that word. That word already exists in and you even don't realize that you have suffixes, prefixes, and so in that word. So this is like a last research technique for Atomian. I always tend to fail explaining Atomian. My engineers, the first session, need 4 hours of, and they don't get anything. So it's difficult to understand, and it's difficult to explain for me. So some examples of things we are doing right now. This dot square is a company that has a structured data set and has a server. This structured data set may be his ERP, CRM, databases, whatever. They must told us how to extract. We transform and load into an Atomian server, and from that point, we work as an API. Atomian entirely works as an API. A user sends a question to the server, and he sends us the question. We just give them back the verbalization we have decided during the integration process. With an example, you'll see better. This is an actual product we are offering to companies, and I'm sure because I'm getting commercial now. This product is integrated with large sets of data in CRM, ERP, financial, accounting in companies. And this is really working. This is something I captured yesterday. And they say, 5 largest invoices we sent during 2014. There you are. This is what Atomian automatically generated. He didn't have that answer prepared, like many other systems. He just generated by thinking in the symbolic way, and at the end, he decided what was the output. This product is using Atomian as an API, and we face a problem right now. Not this one, but also our imagination has limits, and we don't understand how many things can be done with our technology. We are just discovering now. So my message is we are open for business if you think you have a good idea for that. And this is an open challenge we are working on. This is some guy from Silicon Valley who told us, if you can demonstrate that in a logarithmic scale, that the growth of data is exponential while the latency in your response is at least logarithmical, then you can go to your next step, which is this. This is our destination, I would say, for Atomian. Is a general use search engine, not a search engine, a question answering engine that dynamically generates the answers in the way that you can ask for última jornada de la liga, the last table in La Liga, and it will give to you, generated dynamically in that moment, and this you will turn that into an API too if you want. There are many other things. I think it's okay. So I don't get to the next step and I start talking about atoms connecting and showing you diagrams. So do you have any question? Thank you.
Any questions?
Before the questions, let me say,
yeah,
we are hiring. Because we need many engineers here, and fortunately we have the investors, so we are hiring.
Okay,
that's my first message.
It's good to see that NLP is going high, and that you lack of people. So it's good. It's good. Yeah, there will be also predictive API conference for that. Yeah. Do you have a few questions? Yeah, one question here.
I'm going to do it. I'm going to say it. This was fantastic. What is the difference between what you intend to do with Atomian and with what they have been trying to do with Bing, like Microsoft Bing, except for in the enterprise?
When trying to benchmark proprietary systems, you always have trouble. You have to partly guess, partly you turn into a detective. But from what I know from Bing, this is all the Bing search engine and others that they apply into business software come from a company called PowerSet that was acquired by Microsoft maybe 6 years ago. And they had like a system that could turn a natural language query into a structured language. I think it was SparkQL. I don't know if that one was Watson Analytics from IBM, but so the chances of getting right are limited because they prepare some queries, they know what they have in their tables, and when you say you say them a sentence, they turn it into a select, like a select in SQL, that way exactly, but a little bit more sophisticated. But anyway, it's limited. I've tried the Bing search and the Power BI they call in Microsoft, and it's limited. As soon as you get out of the 4 easy questions, it brings you to the easy questions as a suggestion and as an answer.
We have time for one more question. So you know the question I will answer, right? I will ask, right? Oh no, we have one question there. He didn't want to listen my question.
Thank you very much, Miquel. It was a nice explanation. It was a complex field and it's very complex. What's your main difference between, you mentioned Watson before, and I was once in a commercial presentation of Atomian, and you mentioned that you are able of beating Watson in some senses. Don't know. Can you explain or develop a little bit more about that?
I'll tell you that way. Me personally can't beat Watson. The Atomian, because they are hundreds or thousands, but the Atomian technology, and this is something that people in IBM Watson said, has something they don't have, and they don't plan to launch in the next 2 years. So that's our advantage, I would say. And we are trying to, push that way, and let's see if IBM makes an approach to us. That's all I can say, because there's, yeah.
Okay. Now, yes, we will have Andy Trey from IBM that will talk about Watson.
Please let me add, Watson is a completely different system, and I know it very well because I've been there talking with engineers. And I think it's worth to say, what is it? Watson is a super machine that is capable of having non-structured documents, and it's restricted to HTML documents, Word, and PDF documents. They get it, they extract all the possible sentences, they build like a knowledge base from these sentences, and then they pre-prepare all the questions you may imagine ever. They make trillions of questions. And then when you say one, it's very probably that one or a very similar one will be pre-responded. It's completely different. It's very strong. I don't know if that's the way, because we do in our head. We don't need a room full of servers. So there must be an easier way. But anyway, they'll find applications, of course. They're finding applications. But the main difference with Atomian is we do the same, but with structured data, with databases. That Watson has tried, and they have failed. So that's our focus right now.
Thank you, Miquel. Thank you very much. Applause.